Again, welcome back to Inferential Statistics in Decision Making. These lectures cover the confidence intervals for the mean using small samples. Normally, a small sample size is less than 30. When the sample size is equal or greater than 30, we say it's a large sample. So our main objective is to interpolate the t-distribution and use a t-distribution table. We're also going to construct confidence intervals when the sample size is less than 30. The population is normally distributed, and also the standard deviation is unknown. So again, the condition here said when the population standard deviation is unknown and the sample size is less than 30, then the random variable x is approximately normally distributed, and it follows a t-distribution. So t equal to the sample mean minus the population mean divided by the standard deviation of the sample divided by square root of the sample size. Now, the critical values of t are denoted by TC. So the properties of the t-distribution, one is the t-distribution is a normally distributed, so it's a bell shape and symmetric about the mean, which means it's again normal distributed. Then also the t-distribution is a family of curves, each determined by a parameter called the degrees of freedom. The degrees of freedom are the numbers of free choices left after the sample statistics, such as the X bar or the sample mean is calculated. Now, when you use a t-distribution to estimate a population mean, the degree of freedom are equal to 1 less than the sample size. So the degree of freedom is equal to the sample size minus 1. And we're normally going to use the degree of freedom when we are using the t-table to get the p-value or the probability value. So the property of the t-distribution, number 3, said the total area under a t-curve is always 1 or 100%. And also the mean, median, and mode of the t-distribution are equal to 0. And also as the degree of freedom increases, the t-distribution approaches the normal distribution. Now, after 30-degree freedom, the t-distribution is very close to the standard normal z distribution. So we can see the degree of freedom when it's 2, and also when the degree of freedom is increased, we can see the shape of the normal distribution. Now, when you reach the standard normal curve, when the degree of freedom is getting larger, it will reach the standard normal curve. So here we say the tails in the t-distribution are thicker than those in the standard normal distribution. Now, let's see one example, critical values of t. Our question here said we should find the critical value, TC, for a 95% confidence when the sample size is 15. So since the sample size is less than 30, we are going to use our formula. But here we're also going to use the t-distribution table. Remember, the degree of freedom is n minus 1. So 15 minus 1 is 14. So this will take us to the first column, degree of freedom on our table, number 14. Then next, we know the 95% confidence interval. So we go to the row of 95% interval. So the intersection of degree of freedom 14 and also the level of confidence 0.95 or 95% give us 2.145. So that will be our TC. Now, this means 95% of the area under the t-distribution curve with 14 degrees of freedom lies between the t, either positive or negative 2.145, which means from negative 2.145 to positive 2.145, and which we can see from the graph here. So we have the negative 2.145 and positive 2.145. Now, in order to find here, we use the table to find it. Since we know the sample size, we can find the degree of freedom, which will be n minus 1. Then we have 95% confidence. So we go to the top level of confidence, 95% or 0.95. So that's again intersection of 0.95 and the degree of freedom 14 gives us the TC, the critical value, which we call the critical value. So this means 95% of the area under the T distribution curve with 14 degrees of freedom will last between negative 2.145 to positive 2.145. So a C confidence interval for the population mean will be, again, the sample mean minus E to the sample mean plus E, which means the mean will be greater than the sample, the population mean will be greater than the sample mean minus E and less than the sample mean plus E. Now, E is equal to the critical value, which is TC times S divided by square root of N. So here we say the probability that the confidence interval contains the population mean is C. So how do we find the confidence interval in the T distribution concept? So in words and also in symbol, first we need to identify the sample statistics, which is the sample size, the sample mean, and also the sample standard deviation. So to find the sample mean, it will be the total X value or the total sample value divided by the sample size, and that will give us the sample mean. To find the sample standard deviation, it will be each X value minus the sample mean all square, and we add all together divided by n minus 1, and then we find the square root of it. So that will give us the sample standard deviation. Then next, we need to identify the degree of freedom. As we know, the degree of freedom is the sample size minus 1. Then we find the margin of error. If we know the degree of freedom and we know the sample size, we know the confidence level, again, we are almost in our way to find the E. So E will give us TC, which is the critical value, times the sample standard deviation divided by square root of the sample size. But we know we can find the critical value, the TC, using the table if we know the degree of freedom and also we know the confidence level. Next, we need to find the left and right endpoint and form the confidence interval. So the left endpoint will be the X bar minus the E. Now, in order to find the E, of course, we need to find the TC. But if we know the confidence level and we know degree of freedom, then we can find the TC from the T table. Then we plug in the TC times the sample standard deviation divided by the square root of the sample size. Then we can find the interval now. So S bar minus E to S bar plus E. So the mean will be greater than S bar minus E to the S bar plus E. So let's see one example here. Here they say you randomly select 16 coffee shops and measure the temperature of the coffee sold at each. The sample mean temperature is given to us to be 162 degrees Fahrenheit. And also the sample standard deviation is 10.0 degrees Fahrenheit. Now they say we should find a 95% confidence interval for the mean temperature. We are assuming that the temperatures are approximately normally distributed. Now first we look at the sample size. Here they say we randomly select 16 coffee shops and measure the temperature of the coffee sold at each. The sample mean temperature is given and the standard deviation for the sample also is given. So this means our n value is less than, again, 30, so this small sample. So here we can be able to, first of all, write the condition n is less than 30. The population standard deviation is not known because they gave us only the sample standard deviation. So we can use our formula. We know n is 16. S bar is given to us to be 162. The standard deviation for the sample is 10. And also the confidence level is 0.95. So first we find the degree of freedom, which is 15. So if we know the degree of freedom is 15 and we know the confidence level 0.95, then we can find the TC, or the critical value. So the critical value will be on the 15 and also 0.95. So it's somewhere around 2.131. Let's see if that's what we got, 2.131. So now we know the TC. So if we know the TC, we can find the E. So E equal to TC times sample standard deviation divided by square root of the sample size. So it will be 2.131 times 10 divided by square root of 16, which gives us approximately 5.3. So now we know the E, we can form our endpoint. So we form the left endpoint and the right endpoint, which will be S bar minus E for the left endpoint and X bar plus E for the right endpoint. So approximately the population mean will be greater than 156.7 and less than 167.8 with 95% confidence interval. So that's the value we have. We plot our point estimate, which was 162, and we got the left end point and the right end point. So we are 95% confidence that you can say the mean temperature of the coffee sold is between 156.7 to 167.3. But the point estimate that they gave us was 162. So normal or T distribution. Here we say first we need to check the sample size. If the sample size n is greater than or equal to 30, then we use the normal distribution with the z value. Now, when it's no, this is when we use the t value. So we said that if the sample size is less than 30, is the population normally or approximately normally distributed? Is no. So we cannot use the normal distribution or t distribution. Now, if it's yes, here we say if the population standard deviation is no. If it's yes, then we can still use the ZC, the population standard deviation over square root of the sample size. Now, if it's no, then that's what we did in this example. We use the t distribution with the E equal to the TC, which is the critical value, times the standard deviation of the sample divided by square root of the sample size with the degree of freedom n minus 1. So let's try one example here. They say you randomly select 25 newly constructed houses. The sample mean construction costs $181,000 and the population standard deviation is 28,000. Assuming construction costs are normally distributed, should we use the normal distribution or T distribution or neither to construct the 95 confidence interval for the population mean construction costs? Now, what we need to consider is the size of the sample. And also, so let's start first. Use the normal distribution. This means the population is normally distributed and the population standard deviation is known. If the population standard deviation is known. So here we say that we interpret the T distribution and also we use the T distribution table. We also learn how to construct the confidence interval when the sample size is less than 30, which is small. In this case, again, we don't know the standard deviation of the population is unknown. So in this case, we know the sample standard deviation. We can find a critical value because we have to know the degree of freedom. We also have to know the confidence level. So that will be the conclusion of our lectures. Again, in this example here, based on the question, if it's normally distributed, then we use it. We use the population normally distributed and the population standard deviation is known, then we can solve it. So again, wish everybody the best and see you in the next class. Thank you.